Hello, everyone. Thank you for coming. So today we have the pleasure of having three gentlemen here who have the experience of actually working with O3D. So they can provide all of you with a bit of their perspective on what it's like actually working with O3D so that you can go back and use that experience in terms of thinking about building applications on your own. So to introduce myself, I'm Henry Bridge. I'm the product manager for O3D. And why don't we get started with a round of introductions.
Sure. Hello? Okay. Yeah, my name is Brian McRae. I'm the founder and creative director of Crazy Pixel Productions. We developed the Island demo. I don't know if you've seen that or not. And then we're also working on a couple other projects with Henry and his team at Google.
Hi, my name is Wade Tinney. I'm the CEO of Large Animal Games. We're an independent game developer out of New York City. And we developed the Infinite Journey game demo that was featured at the Sandbox yesterday.
Hey, my name's Bob Paradiso, and I was lead programmer on that game.
Okay, great. So thank you. So I think why don't we start out and show actually, in case people haven't seen it, the semi-famous beach demo that we have that Crazy Pixel Productions built for us. Let's see. I don't think we're getting sound.
This
there we go.
potential of rendering high-quality 3D graphics in the browser. Notice the smooth hardware-accelerated rendering and detailed textures. O3D supports advanced graphics techniques. For example, look at the reflection of the water. You can edit the code for O3D applications and see changes in real time. In this demo, use the arrow keys and the mouse to explore. You can also press H to get additional options, such as moving demo elements. To learn more and download O3D, visit code.google.com/apis/O3D.
All right, great. So basically, the genesis of that is we had sort of a pretty loose idea of what we wanted to showcase in terms of the graphics possibilities that you could actually implement and render with O3D. But really, at the start, it was just that. And O3D hadn't even been released. So I was hoping, Brian, you could give us a little bit of an idea of what attracted you to working on O3D initially. And also, since a lot of the audience members here, I think, maybe haven't worked on 3D graphics projects before, what the best way is to interface with an art studio such as yourself.
Yeah. Well, my studio is primarily a game developer. We do next-gen games. But I love 3D graphics. I always have. And when Henry and his team approached us to do this demo, we jumped at the chance to create something fun and exciting and groundbreaking here with them. So they showed us all these really awesome, concepts and island images and whatnot, and we got right to work on creating this demo. And typically what you do when you're creating something like this is lay everything out first, get the environment sort of laid out in 3D. You want to do something that's a little bit more low res, just so you can kind of get the proportions and everything right. We had two artists working on it. One artist was laying in the environment, the other one was doing all the props. And the goal that we had with Google here was, let's really push the graphics. Let's see if we could get a next-gen look. So it was imperative that we used normal maps, diffuse maps, specular maps, just throw everything that we can at it. When we were working on the actual terrain itself, we used a middleware game engine called Unreal to kind of act as like a bar on how far Henry and his team could take the materials and the shaders. So we not only produced everything in the Island demo inside of 3D Studio Max, but we also created a level inside of Unreal. And we delivered both of those, and then Henry and his team were able to extract the shaders and come up with the pipeline that they currently have with their exporter. But yeah, we wanted to really blend the materials, the textures and that kind of thing using, Vertex Alpha, light maps to do the lighting. Just throw everything in like 3 kitchen sinks at this thing to really see how far we could take it. As far as working with a 3D studio, it's a good idea to know exactly what you're looking for your end result. And it's also good to have some assets to just kind of play with when you're getting started. Sometimes, in the early phases, you're not going to need, say you want to do something with a character, you might not need like a fully, articulated character just to kind of get your prototype off the ground. You might want to start with something just far more simple, like just a box or something. Get that translating, get that moving around, have it feel right before, spending the money and spending the time and everything, getting all the 3D, because 3D does, take a lot of time to produce and to get it right. Yeah, I would definitely recommend like a 2-phase approach. Start with some, low-res objects, lay everything in, and then, approach, if you don't have the capabilities yourself at your studio, approach a 3D studio and, really have, some samples of what you'd like to see. If you could hire a concept artist, or if the 3D studio has a concept team available, work that out, figure out what you want for the environments, figure out what you want for the characters, if that's where you're going. If it's something far more, abstract, have those ideas and everything too. And the 3D studio, such as Crazy Pix, will be able to guide you as far as how much it would cost, how long it would take, and so on. I would expect, just for timelines, if you wanted a fully articulated character, expect about 2 weeks or so for that to be complete. In an environment like this was about 1 month time for 2 artists to create.
Okay, great. Thank you, Ryan. So let's also let's talk about large animal also and your project. Let me get up. So maybe Wade, you can also talk about sort of what attracted you to working on this and what sort of the basic ideas were around Infinite Journey, which I hope if some of you got a chance to come by the client pod yesterday, you got to see both of these applications. I'll turn the volume down. Nope. Our buffering didn't work so well. Well,
I
go ahead.
can talk over it. Yeah, so we've been around for quite some time, about 8 years, and we've gone through a couple of phases as a company. And about the last 18 months, we've been focused on social network games, so games that are integrated into Facebook and various open social containers. Prior to that, we were doing PC downloadable games, so we were working with like the Torque game engine and other game engines and doing 3D work. So O3D for us represented an opportunity to kind of combine our expertise in doing higher-end PC games and 3D there with the web-based content that we're most interested in right now. So, and really kind of deliver what we see as the next generation of social network games. So, are we just letting that buffer?
Yeah.
Okay. So, Infinite Journey, the idea with Infinite Journey is that it's a platformer, but the idea is that ultimately it will be integrated into social networks, and all of the levels in this platformer will be levels that are owned and were designed and customized by friends of yours on the social network. So as you're moving through, you are having this infinite journey, right? Because every day another friend may have adjusted their level or added a new level, and we're kind of stringing those levels together. And we can also, of course, take you from one level to one that's been designed by someone else who maybe likes the same music as you or has some other is in your network in some other way, even if you don't have a direct friend relationship. So we worked on it for about 5 weeks. It was a team of 4 and 1 intern. Bob was the lead programmer, and we had a lead artist who was doing concept work and textures and UI design. And then we had a full-time 3D artist doing models and applying those textures, working in Maya, and full-time producer, game designer, and Bob as the engineer. So,
all right, let's finish
roll the
buffering.
video.
Yes.
So the gameplay is pretty simple. It's a platformer, very much like Super Mario or any number of other platformers. What you're doing in the game is you're collecting seeds, and there's a little readout that you can't see in this video, but you're collecting seeds and then you're planting flowers. You can plant wherever there's green, and in order to beat each level, you need to plant a requisite number of flowers. And then this shows the portal that you're unlocking once you've planted that number of flowers. So we have one enemy in this demo, which is the Runkin, which is this kind of little boulder guy who runs around and he eats the flowers that you've planted. So from a gameplay perspective, he provides a kind of time constraint because once you've planted enough flowers, you need to get to the exit before he finds those flowers and starts eating them. And you can also jump on the Runkins, and they'll pop out any seeds from flowers that they've eaten. So.
Yeah, I think everyone was struck by, once you start playing it, you start getting addicted very quickly. You can easily blow an hour, even though there are only 3 levels right now. But we're really looking forward to seeing it built out in the future. So maybe, Bob, maybe you can talk about a little bit sort of what the biggest, what recommendations you have for people that are getting started with the API, and maybe both what you've liked best about working with the API and maybe the things that you found the hardest as well.
Sure. Okay. To speak a little bit to that and go off something you mentioned, yeah, definitely start simple, just so that you got some stuff on the screen. I like to do that whenever I'm starting with new technology. The first cut of the game just had what was it? There was a sample crate you had with with your model viewer, and the first level was nothing but the ground was built out of crates, and you were a little crate that would jump on those. And he'd run around, and that was really good because I was able to hand that off to a guy to start tweaking physics parameters and stuff. And as soon as that started to come together, the animation guy could, start getting jump animation and stuff like that that kind of matched that kind of physics motion. I really I enjoy doing 3D work, and I do enjoy platformers a lot. So this was a great project to be working on. I think the thing that was challenging for me, one thing that was challenging was I was new to JavaScript doing this, so that was a big thing to learn. But that came together, and as far as let's see, well, it was just really helpful to have a dialogue between us and Google as things were coming up, working that stuff out. I don't know.
Any tips or tricks that you found? Well, I mean, other than prototyping, I think that's a great sort of lesson.
Prototyping's a good thing. There's JavaScript stuff I'm sure you guys know. Like, for example, garbage collection. That was a big thing in the game. Optimizing towards the end to get it working. So, making sure you don't allocate a lot of stuff while the game's running, and also there was. Yeah, I think just kind of doing performance stuff as you're working on the game is important to kind of see how much you could throw in. But it took a lot more than we. It took a lot of stuff that we were surprised, and it took it really well. So.
Okay, great. And actually, so Crazy Pixel is working on another project, and has been producing art for a tower defense game. Oh, and this one hasn't buffered either, but. Maybe you can talk a little bit about that, and since you've had development expertise with O3D as well, what you've liked most and what you found the hardest in terms of working with the API.
Sure. Yeah. Okay. So the Island demo was easy for us because we're primarily an art studio specializing in next-gen graphics. So that really came natural to us when we started approaching this project, which is a tower defense game. We wanted to really, on the art side, we wanted to specifically use what's available stock in O3D. So, the Island demo had a lot of custom shaders that were handwritten in JavaScript after export. And our approach on this one is to, to act as more of a typical end user and export the characters, objects, that kind of thing, without doing any custom scripting of the materials afterwards. And we're finding it to be very very forgiving for sort of a game engine, quote unquote. We're able to skin the characters using the skin modifier in 3D Studio Max to any kind of custom bone rig that we have. And typically in a game engine, you could only use like 2 or 3 bone weighting, and you wind up exporting your object, and it turns into like spaghetti, or the vertex rig gets all messed up, and we haven't found any problems like that whatsoever with O3D. So I use the word forgiving, when that kind of thing just kind of happens, and it just works great, first round. The materials, everything comes through with specularity, which is great. The fall off and the glossiness and all that kind of parameters inside of a standard Max material are all retained and exported. The diffuse map, you just stick it in the that map channel. The normal map, you stick in that map channel. Specular map, translucency, even multi-sub objects, all work. So on the material and the modeling side, and even animation, everything has been coming over great. The first tool that we needed to make, because you do need to make tools when you're creating a sort of a game, is for the artist a model viewer. And it was a luxury to go to the API site and just kind of grab from all these different samples and piece together what we wanted, because we knew we wanted to be able to load an object, load an animation, see what the frame rate is, be able to rotate around the object so that the artists know what to do to get it to look how they want it to. And so that was the first tool we made. It only took 3 days, and after that, we're able to just go full sprint on our on all of our characters and objects for the tower defense game. And then the other side, of course, is the programming. And like I said, we're mostly an art house, so when we approach the programming, we also use Torque Game Builder and that kind of thing for our own internal game development. And so we're used to scripting languages and that kind of thing. And there was a little bit of a ramp up for us for the JavaScripting. The fact that everything for the runtime on the canvas is all exposed into that one main instruction that runs the canvas was a little new to us. And something else that we were kind of scratching our heads on is the fact that every object needs to be parented to a transform, and then you manipulate that transform through your own custom variables, as opposed to getting and setting transform positions. So some slight differences, and we actually, after thinking about it, the fact that the transforms are so modular to the objects is kind of a luxury, because then you could swap objects out to different transforms pretty easily, and it's actually kind of nice once you get used to it. So just a couple of things that were a little new to us, but we're well underway, and I believe we're going to have the game done in about a month and a half, and it's been a lot of fun to work on so far.
So I'm a little bit new to being on stage, so I'm a little bit nervous. I'll probably avoid eye contact and stuff. Sorry about that. But just to speak to some of that stuff, that was interesting. We actually, in some ways, we did it from a little bit of a different angle. For like the art side, we found that although Maya did export the settings out to O3D with some fidelity, that was really good. We found that, I guess, especially since we had a separate 3D artist from a texture artist, we found that it was more useful to externalize the textures and the normal maps and all those other settings. And we had it such that the 3D modeler would export it once, and then since all the other stuff was externalized in XML files, the texture artist could go ahead and tweak that stuff till he was happy with it. And that was how we separated that out. The transform thing was interesting too. That was a little bit new. When we were doing this platformer game, what we wound up doing was we set up like just a basic class that was just a model, and he would own a transform, and he would own his rotations and positions, and every tick, the physics would tick by, and it would update his position, and then we just had code that would then push that into the transform, and then O3D took care of the rest of rendering that out to where we needed it. So, yeah, that was our way of getting around that stuff.
So I have sort of a general question for you all. So looking out at the world of 3D on the web right now, there's a lot of excitement, there's a lot of activity. So there's Google's O3D. Mozilla also has its Canvas 3D technology, and we're working on that with them also in the context of Chronos. For those of you not familiar with Canvas 3D, it's basically direct OpenGL bindings from the browser. So it's in contrast to O3D, it's what's called an immediate mode API rather than a retain mode API. And if any of you were at our talk yesterday or would like to see it, you can find the videos that talk more about the technical details online. So looking around at what's sort of happening on the web right now, what direction would you like to see all of this take? And do you think what's emerging right now is what's right for developers and what developers really need from 3D APIs for the web?
Well, I mean, I think the direction I'd most like to see it take is towards some kind of standard. Mm-hmm. I think, we'd love to see this technology native to all the browsers, or at least the modern browsers. So we've been working in Flash for a long time. We're a Flash studio primarily these days, and we're comfortable with that plugin because it is propagated so widely. So that's the real challenge of any of these technologies. I mean, we love the fact that we can have the kind of performance that we have in this game and the kind of lighting and 3D assets that we have in this game. And it opens up a world of possibilities for us, and the fact that we can so easily access other web services and connect into the social graph, and that just presents an amazing opportunity. So then the question is, well, how can we make sure that accessing it is seamless for millions and millions of just average users, right? So where we want to see it go is just wide distribution of great content that drives that access.
Yeah, I kind of see a bit of a rebirth here of what happened when Flash came out, in 3D. So I think it's really exciting. Yeah, I remember, back when Flash came out, everybody had just amazing intro Flash videos on their websites, and that was when we all had 5K download on our modems or whatever, and it was just awesome to see all this motion and everything happen on our little modems. Nowadays, things have progressed so far in just the last 10 years. Now we have this. I think it's mind-boggling to think what could happen, not just in an intro, sort of video to get people into your website, but what if the intro video turned into your website? I just saw Terminator Salvation, and we've all seen, these crazy, awesome movies where there's a computer interface, and it's like this huge network in 3D space, and people are flying to these different nodes or whatever, and then information's coming out at you. What about websites like that? I think that could be really awesome. Aside from the fact that you could do entertaining applications like games. So I think there's just a world of possibilities available to us, and the bottleneck, I believe, is going to be just the developers, us, authoring these applications, these experiences. I would love to see somebody do like a Flash or a Photoshop sort of a tool to author within this, so that a 3D artist who doesn't really understand JavaScript could piece together Java code, bring in his assets, adjust lights and materials, all that kind of stuff within some kind of a game editor or authoring tool or something like that. I think that would really open it up, and it'd be an amazing time to see what comes from something like that.
Yeah, sure.
So, yeah, I mean, that actually reminds me, we were talking over dinner last night, and one of the things that, as we were working on it, as Bob mentioned, we always look to externalize assets as much as possible, so that other people in the team can tweak and adjust those assets without taking up Bob's precious time. So, we did that with models, we did that with textures, and we would love to see that something similar happen with shaders, and we always do it with text and copying the game. So then that started me thinking, well, if you had kind of public repositories of these different types of assets, so you had a public library of models and another of textures, another of shaders, and so on and so forth, then you could let really, independent developers who don't have a team with designers and artists, maybe just an engineer or maybe just an artist that's working and pulling, functional code modules for different character behaviors and world descriptions, that they could just kind of be pulling from different libraries and creating, doing quick prototypes of different common game types. I think that this is a step in the direction of making something like that possible.
Great. Well, with that, I actually wanted to open it up to the audience to ask any of us questions about O3D, how to get started working with it, tips and tricks, anything like that.
Did you guys use the embedded V8 at all?
Actually, for our game, we didn't. We're definitely going to look into doing that. We were able to get pretty good performance even without doing that. It was a short timeline, so that was kind of a lower priority since we were able to get the frame rates we wanted.
Hi, I have two questions. One is, what do you think about the Canvas 3D and the O3D, and what will happen to O3D as Canvas 3D becomes more popular or becomes more of a standard? Or is one or the other going to become one of the standards?
Yeah, so I'd say we're very supportive of the Canvas 3D work. We're actively collaborating with Mozilla and Apple and Opera on standardizing basically what is Canvas right now in the context of the Kronos organization. And we really want to see OpenGL bindings available in browsers. I think we still have some concerns about performance in some situations. So particularly in things like, like the beach scene where you have a lot of different objects. We're just concerned about being able to actually draw all of that in 16 milliseconds, as that's basically what you need to do if you want to get a 60 frames per second. So I think over time, since we are collaborating with Mozilla, I think we might see over time that there are sort of two APIs that wind up emerging. And a good analogy that Matt Papadopoulos was using yesterday was that you'd say of Canvas, which is an immediate mode, and SVG, which is a retain mode API for doing graphics. But what we'd like to do, since we are working together with them, is have the two work seamlessly together, so that if you wanted to, for example, set up a huge scene, but then draw a foreground that's animated every frame, you could do the background perhaps in retain, and then do the foreground in an immediate mode API.
Okay. Second part of my question is that has to deal with performance. Have you done any real tests of how much data can you handle in O3D in terms of loading polygons? I have a system that previously was worked on by people at Stanford, where we have a client and server environment. On a server, we're actually loading millions and millions of polygons, like 100 million polygons. Whereas on the client end, we load a very low res, and we have a sort of fake animation where you're able to rotate the models and do whatever navigation you need to, but then in the end, you do get a high resolution model. What I look to do is convert my client to something like O3D, because right now it's running in Java, or Canvas 3D. But I like to know how many polygons can handle.
Yeah, I'd encourage you to try. We haven't done any actual sort of benchmarking and seeing how many objects you can get on the screen. One of the tough things, though, is, since it is a PC platform, we're very dependent on the hardware that's running underneath to some extent. So it's going to vary a lot based on the individual user's machine. So so I'd encourage you to do some testing. I don't know if you all had some experience in sort of a mid-range machine what you could actually get on.
More specifically, I should just go back into what can the Ajax and the JavaScript functions handle. Not necessarily, because I know it goes through OpenGL, but I'm assuming there is a JavaScript limitation of some sort. The API has some kind of limitations, where the browser times out, or you can't load certain things in.
Well, I mean, right now for getting actual content into it, in the plugin we have essentially a streaming API that allows you to pull down a tarred gzip archive of stuff. And basically, if you've constructed the archive right, you can actually also sort of load it progressively. But I don't know that we've seen any type of specific limit in terms of timeouts of amount of content. I don't know. Any?
Well, I can give you the non-engineer's perspective on it, because I was asking the same question at the beginning, like, because I was involved with the game design side, like, what is the limit? What are the constraints that we're working towards? And, the people on the team patiently explained to me that it's a difficult question, because, you can keep putting crates onto the screen until the computer crashes, and then you know how many crates you can put on the screen, but once the crates have different textures, and some crates are, crazy tetrahedrons and or animating, and you have, collision detection happening, and different machines, and all these things start to make it it's really about figuring out what you want to accomplish, getting as close to that as you can, and then pushing and pulling until you find the boundaries. I will say that I was amazed at the fact that we never really hit that performance barrier with our game, and I encourage you to play it. We're going to make the demo available on our website in the next week or so. But I think I have the oldest computer in the company for some reason, and I think it's a 3 or 4 year old ThinkPad, and it runs totally fine on that. And some of our pre-optimized Flash applications chug on my machine, and so I'm pretty happy about that. I don't know if you have anything to add.
Yeah, that's about right. I mean, it's like a running joke. His laptop is the one we tested on before we put it out to the world, because it's the lowest end common denominator. Just to echo what you said, it's really like, at least we found from a rendering end, some of it's like, what are you doing with those polys? What was the complication of the shader? What's the complexity of the shader you're using? We hit more of a bottleneck with what you're doing with the JavaScript. We had to be more careful with that, how we were doing our math, how we were using memory and stuff like that than we did from the rendering end. But we found ways around all that stuff.
Yeah, so I worked on an Xbox game before we had an Xbox dev kit. And so I have some experience on, just how you go about finding the constraints and restrictions that you're dealing with when you're working in a new platform such as this. And, the dust is eventually going to settle. Everything is really brand new right now. So there's a lot of, testing that needs to happen. For instance, with Xbox, we found that the thing that was the biggest hit was just the bone counts on the characters. And that's why you eventually saw games that had, 50 or so or 100 characters on screen. And then you could approximate their collisions by, just putting big spheres around them and that kind of thing. So, we found that it was bone count, and it was collision detection, and then, environment polygons and that kind of thing started, seeping into, along with the amount of materials that you had. So I would expect that same sort of, pattern to follow here to some degree, but you never know. We might be surprised. Maybe it handles bones great. It's just running through the actual translations of the bones is what slows us down, and then we find some kind of optimization there. Maybe it is polygons that slows us down. Maybe it's just the JavaScript code itself is what's the slowest thing that holds everything up. So it's exciting, and I think it's going to be up to the developers to find what happens.
Yeah. So what I'm gathering here, I was going to ask a question similar to that. Did you find it was more the JavaScript side, or did you find it was the underneath side? I'm gathering it's the JavaScript side. So what I did once, just to play with it, was I had the discrete card, looked at see what frames per second I was getting, ripped out the discrete card, and saw what the CPU would do with it. It was probably about a 15 to 20 frames per second difference between the two from the hardware and software. The other thing that I thought was interesting was that the CPU jumped up 40%. So, but what you're telling me is it's a little bit different, that it requires more processing capabilities from the JS side. It's where you guys ran into bottlenecks. So my question is are you guys going to characterize some of the performance that you have, or is there ways to characterize it so that we know exactly, what we can do from both ends, either the native side, which is, the DirectX or OpenGL versus the JavaScript, and see where the bottlenecks are?
Mm-hmm. I would say I'm not sure to what extent we will characterize it fully. I think one of the things that is very interesting to us is basically creating a suite of benchmarks of what the common operations are that you have in a 3D application. So anything from sorting to collision detections in physics and things like that. Because we found over and over again with browsers in general that the second you make a benchmark, particularly a JavaScript benchmark, everyone jumps on it and tries to make it faster. So I think something like that will be a good guide, also in terms of figuring out applications, but will really provide a way for all the browsers to improve the JavaScript performance, which is increasing at blinding speed right now.
And another thing just related to that quick is sometimes there's workarounds that the plugin gives you. Sometimes you'll be doing a lot of matrix math, which doing it in JavaScript, it's a little bit slower than you'd like it to be sometimes. But the plugin does allow you to do some matrix math within it. So when I switched to doing that, in some cases that, of course, sped up things a lot. So you just got to, look around and you can find ways around it.
Hi. I'm a web application developer, so my question is, do you see a way in which O3D could find a spot in web applications beside games? I mean, if you had to redesign Gmail or Basecamp or whatever, or YouTube, in which way would you use O3D to make the application richer?
Well,
go ahead.
There's a couple guys sitting right behind you, actually. They could probably speak. You should find them after. Guys, to the other side. There was one of the sandbox demos was a team from ABC Disney, and they had done a kind of experimental O3D interface to a catalog of their video content. So I think there's a ton of possibilities. And for me, the interesting thing is, I think we've probably read about the fact that humans can understand and wrap their head around full 3D spatially positioned objects quicker than 2D. Like your house, where everything is in your house, and that's a lot of different objects. So I think there's a huge opportunity there to explore more experimental interfaces that take advantage of that just cognitive fact.
So I think some ideas that we have, I think that there's a lot of potential, as Wade was saying, in data visualization stuff in terms of representing lots of data, whether it's actually representing the location of an object in 3D space, or interfaces, maybe a photo browser or things like that allow you to flip through photos very fluidly. I think there's also a lot of applications that you could think about in terms of any product that has a physical component. So we have a sample on our site which allows you to take furniture from a sidebar and drag it into a scene, move it around. So you can imagine shopping for furniture or other products that way. I think what's going to need to happen in order for that kind of content to be created is O3D is still very low level. We're probably going to need some even higher level JavaScript APIs in order to really make it easy for people to do that. Things like, if you think about analogies of like jQuery or MooTools and all of those sorts of JavaScript frameworks that make it easy to do a lot of the common Web 2.0 kind of effects and things like that. So if you have ideas and 3D experience, I would encourage you to build something like that and send it around, because we're just dying to see that happen. The question was, how about porting Google Earth to it? That's something that we'd certainly like to see, but we don't have any plans to announce right now.
Yeah, I'm curious about the data format for the art assets. Like, did you use a standard one like Collada or some other format? And then also, after it was in that format, did you have to compress it into a binary for then when you had it like running in the game, or was it you could just leave it like flat?
We get that question a lot. Actually, we don't have any native data format in O3D. Basically, what we've provided is a binary that you run offline that lets you take Collada and convert it to a compressed JSON file. And then we provided a corresponding JavaScript file that when you want to unpack that archive in your application, you bring in that JavaScript file and essentially run it to recreate the content that you had created. But it's not actually a data format in that what we've provided is really just a sample implementation. So if you had content that you wanted to include that was unique to your application, you could take our converter, which is open source, and modify it to include other information in the archive. And you could provide your own corresponding JavaScript library so that the application developer has total flexibility in terms of file format and what content to include.
Because that's like on the OpenGL side, but like for you guys, for your game, like you came from Maya or 3D Studio Max, so like obviously it's not going to read in a Max file or a BIP or like how, like what were the...
Yeah, I think a less technical, I guess, answer for you would be yes. You export a Collada file. We use Collada Next Gen. It's a special, I guess, Collada exporter. It's free. And so you export as that. You take the DAE file and you drag it over a tool that Google has made that sort of packages everything up. So the Collada file, stores paths and everything to all your textures and all that, kind of stuff. And then when you condition it with the tool that Google supplies, it makes a TGZ file,
yep,
I believe, which is essentially like some kind of an archive file that has everything all in it. So it's got your mesh data, it's got all your textures, it's got your material information, all that great stuff is then all packaged in there. And then all you got to do, if you want to see it in the in the O3D canvas, is you just load that object or that package, and there it is.
So is that the open format that you provide, like an example of how it's zipped up and run through the OpenGL libraries? Or?
Yeah, exactly. We provided essentially a sample that does it for Collada, but the way that we've implemented it and the level at which it's exposed is anyone could build whatever they wanted on top of it. So if you wanted to natively support something like FBX, you could build something to do that,
okay,
or whatever format you wanted to do.
Okay.
Yeah, really we were trying to, again, provide the plumbing at sort of the similar level as OpenGL or DirectX would, and not try and make any assumptions about what the developer is trying to do with it, so that we could define a file format maybe that was specific for games or specific for photos or things like that, but we want to enable all of those things and not just one.
Hi, I'm just curious, as you continue to develop O3D and you get closer to moving people using handsets like the Android handsets for browsing the web, how does O3 play in the mobile space, considering that right now the current implementation is heavily dependent on like the OpenGL, not OpenGL ES 2.0 or 1.0 and so forth?
So I think basically the level that we shot for was, we think that programmable graphics is basically the future of where graphics is going. So we chose to support that and that only right now. I think what you're alluding to is that some of the handsets on the market today don't actually support all those capabilities. Really, what we're very interested in supplying O3D and 3D graphics for the web capabilities for mobile handsets as well. We're hoping that Moore's Law and sort of how quickly people replace handsets will help us through that, and that basically if all of the handsets that are being produced today and that are coming to market will support OpenGL ES 2.0, which provides the functionality or a similar set of functionality as we require with our API. So we're betting on the future a little bit, but it's definitely something that we want to look at.
jump in one more time. Have you thought about encryption, data encryption, anything like that?
So we don't provide any encryption or DRM type of solution. It's a question that we get a lot from content developers. Our main suggestion in that regard is that if you're really concerned about protecting at least your code, you can use JavaScript obfuscation and compilation in order to do a lot of that. But
I'm thinking more in terms of the 3D data rather than the code itself.
The 3D data, we don't provide any support for encryption. So maybe all of you can talk about what your thoughts were about that. But what we found in talking to developers is that they're more concerned with protecting the actual code and their shaders rather than protecting the assets. Since most games that you buy today, if you really want to, you can unpack all the assets, and it really becomes sort of a legal issue of enforcing the IP in that respect. But I don't know if you have other thoughts to add there.
Yeah, we did think about the code and the shaders doing obfuscation and stuff like that. As far as the 3D assets, I have a question for you. Since we do have access to the importer and all that stuff, we could write our own encryption, decryption stuff, right within the game code itself. So you could maybe roll your own at that point. That may work out for you.
Sure, that's a great idea. Any other questions?
Perfect clarity. We've reached perfect clarity.
Right, exactly.
In all things.
Everyone knows what O3D is and how to use it. Sorry? Could you use the... So the question is, do we have a lot of sample code? And the answer is yes, we have a ton of sample code. So I think we have over 40 samples at this point, and we're adding to it all the time. It's code.google.com/APIs/O3D. So if you go there, you can browse it, and if you have the plugin installed, then you can view a lot of things, including the beach demo and the demo that Greg showed off yesterday. We'll also be posting. Another neat thing is, since O3D is completely open source, all of the samples and the assets to the samples and all of that is also open source. So if you want to create a mashup of a robot dancing on an island or something like that, you can certainly go ahead and do that. Kung Fu movie. Oh, okay. Definitely.
Also, I just wanted to mention, we're going to be posting over the next couple of weeks a bunch of kind of behind-the-scenes information and images from our process of working on it over those 5 weeks, and looking forward to connecting with people. And if people have questions for us, we're happy to answer them, and we'd love to get a community of developers going around it.
Awesome. So if no one has any other questions, thanks a lot, and I think we'll stick around here if there's anything that you didn't want to ask on the mic. Thank you.